Hello friends, today we are going to see Liskov Substitution Principle. It is the one of the solid principles. So the definition of this principle is subtype must be substitutable for their base type without altering the correctness of the program. Meaning, so I have created one graphics for this. In simple words, if you take example of taxi service, and there are like two subtype for taxi service, one is regular taxi and pull taxi. So let's say you have created an object of regular taxi and you're calling calculate fare method. So as per the Liskov substitution principle, if you replace pool taxi, which is again like subtype of taxi service, with the regular taxi, then also it should work seamlessly. This is about Liskov substitution principle. Now let's understand it through example. I'll take one bad example and another one is good example. Okay, so start with bad example. So here I have a taxi service and I have two subtypes as a two subtype of this taxi service. One is regular taxi, another one is pull taxi. Again, like my regular taxi is having some method and my pull taxi is also having some method. So let's say if I want to create a taxi service and call a book ride method, then here, for example, I have created a regular taxi with the regular taxi object and I'm calling this book ride method with some parameters. Then I have created pull taxi and I'm calling this pull taxi method. So in this context, here the pull taxi is throwing an unsupported operation exception. That means if I'm trying to replace pull taxi with regular taxi, or if I'm trying to call book ride on pull taxi, it will give me an error. So now you can like imagine, let's say you have some kind of API where like user has an option to choose regular taxi or pull taxi, and if he click on book ride button, so in both the ways he should get similar result. He should be able to book his ride. But in current case, in case of pull taxi, it is showing unsupported operation exception. And here, like we are violating Liskov substitution principle. Now let's understand better it with some like another good example. We'll fix this issue in a good example. So here, simply like our pull taxi is having book ride method, and this method is able to book the taxi for the user. So because now we can interchangeably use a regular taxi and pull taxi, so this is following Liskov substitution principle, right? Now this example looks similar to whatever we learned in our previous video, open close principle. Yeah, they are very close. Liskov substitution principle and open close principle, they are very close to each other, but they are they're talking about different things. For example, open close principle is talking about to extending the functionality so that we should support the extension of the functionality without making any changes to previous code. Here we are talking about replacement of subtype. So here the context is different, though they are looking similar, but the context is different. Yeah, this is about Liskov substitution principle. We can take a bit more complex examples, but just for a simplicity, I have taken this pool taxi and regular taxi as an example. And here I have used abstract class and I'm making subtype of taxi service, this regular taxi and pull taxi. But we can create an interface here, not an issue, because like Liskov substitution principle is talking about base type and subtype. So parent-child relationship, kind of parent-child relationship, and in Java we can create parent-child relationship using abstract class as well as interfaces. So feel free, you can replace this abstract class with interface also, and similar example will work as it is. The 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 gist is, if you replace the subtypes, it should work seamlessly. Yeah, this is about Liskov substitution principle. Thank you guys.